Okay, this video is going to start looking at graphs of rational functions. So if given like multiple choices, how do you decide what the graph should look like? All right, so I'm just going to do several examples here. So let's take a look at, let me see if I can make that a little smaller so you'd see all four possibilities, just about. Okay, there we go. All right, so this first example, I'm going to have to take a snip of these so I can work with it. Okay. All right, so the first example was we're trying to think about what that would look like. So you kind of consider asymptotes and that sort of thing. So when you look at the denominator, the asymptotes are where the denominator would equal 0. But if you look at the denominator, see how that whatever you plug in for x gets squared, which is going to be positive, and then you're adding a positive number to it. So that means you're going to wind up with a positive number down there no matter what. You're never going to get a 0. So that tells me there are no vertical asymptotes whatsoever. Okay. So that means I can't have this, can't have that, can't have that. That leaves D for my answer. So that rational function, if we were to graph it, would look something like what you see on D, must be. And you can do these by plotting points, but it's just, these are very strange functions. And so it usually takes more than just plotting a few points. You really have to have some idea of what to expect. Okay, so we know it can't have any asymptotes. The other thing I know is it's positive 18 on top. Okay, and then it's this x squared plus 9, which I know is positive on the bottom. So no matter what I plug in for x, the value of f of x is going to be positive. Notice that everything is above the x-axis. So that's another reason why that looks that way. And then see how it appears to have the high spot at 2? That's because the smallest this can possibly be happens when you let x be 0. See, if x is 1, 2, 3, or 4, okay, you're going to square it and add 9, okay? And that makes the denominator bigger and bigger and bigger. So if you pick x's that go towards positive infinity or pick x's that go towards negative infinity, the denominator gets bigger and bigger and bigger, which makes the whole entire fraction smaller. So see how it's approaching the x-axis from the top and approaching it from the bottom? The smallest number you can plug in for x is 0. When you square it, that's not what I meant to say. That produces the smallest number in the denominator is when you plug in a 0 for x. Then the denominator becomes 9, which gives you a 2, and that's why that's the highest. Because that's the smallest the denominator can be, which makes this as big as possible. Okay, so those are a couple reasons why that's the right choice. Okay, let me go back to the original document. We'll look at another example and try to analyze it. Okay, so here's the next two examples. We can take a snip of that. And if you're going to use technology to try to graph these, make sure if you're typing it in that you're doing this. You're taking the whole numerator divided by the whole denominator. So if you're going to use technology, make sure you put those extra grouping symbols on there before you type it in. All right, but let's think about this one and why it turns out the way it is. All right, so what's going on here is the denominator would be 0 if x squared were equal to 4, which means if x were 2 or negative 2. Okay. All right, so at 2 or negative 2, you're going to have either a 0, either a whole or an asymptote. All right, now the numerator is 2x squared. Another thing I could have done is just factored that denominator to make it more clear why 2 and negative 2 have to be excluded from the domain. And then do you see how there's not a factor of x minus 2 or x plus 2 on top? So you can't eliminate the problem. So that's why both of these are going to be vertical asymptotes. They're not just going to be holes. So you should have on this one, you should have vertical asymptotes at 2 and negative 2, which means B is out. But then it's either going to be A, C, or D. All right, now here's another thing to notice. Notice the squared is the 2 on the x, the squared. That means that the degree on top and the degree on the bottom are the same. Okay, so that means you're going to have a horizontal asymptote, and it'll be at y equals 1. All right, actually y equals 2. That's a 2x squared. So take the leading coefficients. Let me stretch this out a little bit. See how that's 2x squared over x squared? So 2 over 1 means you're going to have a horizontal asymptote at y equals 2, not at y equals 0. Okay, not at y equals 0. So it's got to be this guy here. And then you can plot points just to double check to see if you're in the right vicinity or not. All right, let me back up to that previous snip a minute because I forgot to mention horizontal asymptotes on that one. Let's see. Let me go back to my other snip. Okay. All right, so like on this one, see how the degree on the bottom is 2 and the degree on top is 0? So the degree on the bottom is bigger. That means you're going to have y equals 0 for the horizontal asymptote. And that's why it approaches the x-axis. Okay. All right, let's look at 14. All right, so let's see what's going on here. Let's do horizontal asymptote real quick. So the degree on top is 3. The degree on the bottom is 2. So the degree on the top is 1 more than the degree on the bottom. So what that tells me is I'm going to have a slant asymptote, and the equation of it would be y equals something in this form. It's going to be linear because x to the third on top, x to the second on the bottom, the numerator is 1 more than the degree of the denominator. Okay, well, that's enough for me to know it's got to be D. But let's analyze a little bit more. Okay, the vertical asymptote, or the holes happen when the denominator is 0. So see how that x squared minus 9 can factor into x minus 3, x plus 3? And notice on top, you can't break that down anymore. So you're going to have a vertical asymptote at 3 and at negative 3, not just a little hole that can be fixed. So notice how all of these have the vertical asymptotes where they need to be. Okay. All right, and then you always can do things like if you plug in 0, you'd have 0 on top and negative 9 on the bottom, right? So if you plug in 0 for the top and bottom, you're going to get 0 over negative 9, which is 0. So it's got to cross at 0, 0. So that one's out because it doesn't cross at 0, 0. This one crosses at 0, 0, but there's a different reason why it's out, and that's because that horizontal asymptote should not look like that. This one's at 0, 0, okay, but it has a horizontal asymptote right there at the x-axis, so that's out. All right, and then to find that slant asymptote, if you really needed to find the equation for it, you could take the x squared minus 9 and divide it into x to the third. Okay. And so when you do that, you would, since it's not a linear factor, you would have to use long division. So you might want to put some placeholders in there. Let me write it over here. We're not going to take the time to do this. I'm just kind of setting it up. You'd put the placeholders in like this. And then you'd say x squared goes into x to the third, x times, and then multiply back. Okay. Then you'd subtract. So that would change these signs. That'd be gone, and you'd have 9x. And you could bring down the 0. And then you could go again, okay, but it doesn't really go again. So it just turns it out to be the y equals x. And then you've got that remainder. So that's the y equal x right there. So when you do it, it would turn out to be x, and then you'd have 9x plus, or just 9x, over x squared minus 9 left. All right, you don't normally have to go on and do that, though, on these. All right, so we're just kind of analyzing some graphs to understand why they turned out the way they did, like which one's correct. All right, let's look at another one. Got one more. Okay. All right, so here's one. All right, and this is x to the third over x squared plus 4. Okay, so degree on top is one more on top. So you're going to have a y equals mx plus b. Notice if you were to divide, it would be a positive x, so you know it's going to have a slant asymptote of some sort that goes up. Okay, so this guy's out and this guy's out. All right, and then let's look at the x squared plus 4 in the denominator. See, that's going to get squared, so that's going to always be positive. Okay, you're not going to be able, this right here has no solutions. You're not going to be able to find an x that causes that to equal 0. So that means there are no vertical asymptotes. So that guy's out. So it has to look something like that. And it's just doing kind of a little squiggle there. So it's a strange graph. A little bit of squiggle right in here. It'd be nice to blow that up a little bit and look at it. All right, now we're kind of reversing the process. These are really fun. We're trying to decide which of the following would have a graph like this. So we can use process of elimination here. Can't be that. I know that's a parabola. And then these, you might have to do a little plotting of points and that kind of thing. 1 over x looks like this. This one is actually the answer, 1 over x squared. It winds up having both pieces. It has some symmetry to it like that. Okay, 1 over 2x looks kind of like that one. It's just a little more stretched. And you could plot points to find that too. All right, here's another one. We're just trying to match the graph with its possible equation. So you just notice something about the features. See how it has a horizontal asymptote at y equals 0, and it has a vertical asymptote at x equals 5. Okay. The vertical asymptote must have come from having an x minus 5 in the denominator. Okay, and then the fact that the horizontal asymptote was y equals 0 means the degree on the top has to be smaller. Okay, so it can't be an x or anything like that. So first off, I know the denominator has to be x minus 5, so I can get rid of those. And then I just don't know whether this should be a 1 or a negative 1. And the 1 versus the negative 1 has to do with where these pieces are oriented. Like, here is your vertical asymptote, whether it does this or whether it would be the other way around. Okay, and so you could go and plot a point and kind of see what it appears to do. Like, look at 4. If you plug in a 4 to this one, you'd get 1 over 4 minus 5. Ooh, can't hardly read that. Okay, if you plug in a 4, you'd have 1 over 4 minus 5. That would be 1 over negative 1, which would be negative 1. But if you plug in a 4 on this guy, you'd have negative 1 over 4 minus 5. which would be -1 over -1, which would be positive. But see how when you plug in a 4, you have to be in the negative area of the graph? So that allows me to eliminate that one. I know that would be 1 over x minus 5. You can also think of these by shifting. If you knew that y equals 1 over x looks like this, then if you replace the x with x minus 5, it's going to move over 5 units. That's another way to know that. Okay. Let's do some more graphing type. Okay, let's see. All right, so here's 18 and 19. Two more where we're trying to figure out what the equation might be that has a graph like that. All right, so let me go ahead and snip it. All right, so decide which could have this graph. So we'll use process of elimination. Okay. All right, so we're going to look at it. I like to first look at the asymptote. So we have a horizontal asymptote, and that is at y equals 0, the x-axis. We have a vertical asymptote. We have one at x equals -2. We have another one at x equals +3. All right, those vertical asymptotes are going to come from having a factor in the denominator. Okay. So if you get a vertical asymptote at x minus 2, it comes from having a factor x plus 2 in the denominator. And if you have x equal 3, it comes from x minus 3. All right, so far I know this guy's out. Okay. All right, now let's think about this. Okay. All right, it's going to be A. I'm trying to think about how to explain that it's not D. I have to think about that. I can't think about how to explain why it's not D and what that would do, but it's going to be A. No, it's not. It's going to be B. It's going to be B, and I'll tell you what made me say that. See how this in the middle is falling in the middle? Okay, so it's almost like it has a negative slope. I'm looking at this 2 minus x and thinking of it as a negative x plus 2, like it has a negative on it. And that makes it have that look where it's falling rather than rising there in the middle. That's what I'm thinking. Okay, I better think about that one some more. I'm not positive about that. Better do that may not be true. I better look at that some more. So let me go ahead and just plot a point to make sure I'm not lying to you. So let me pick a point like, let's get rid of that so we can see. Let's pick a point to see what it would look like if I plugged in, say a -1. Okay, if I plug in a -1, I would get negative. Keeps jumping. If I plug in a -1, I would get -3 on top, and I would get 1 and -4 on the bottom. So I'd get a +3/4 if I plug in a -1. So far so good. That seems to fit. But if I plugged a -1 into this one, I would get a 3 on top. And then if I plugged in a -1, I'd get a 3 on top. But see how I'd get a 1 and a -4 on the bottom? +1 times -4. See how that would turn out to be -3/4? So actually that one's out. So kind of thought I had a good handle on it about what that middle part would do, but I really did not. Should have plotted the points just to double check things. And really, I should have realized it was this, because this kind of looks like the typical 1 over x graph, except for that part in the middle. Okay, so it's going to be that A. All right, let's analyze number 19. Ooh, that's interesting. Which could be following functions could have this graph? I thought of something else we haven't talked about. Maybe that would be good here. That would be good here too. I also should pay attention when it crosses the x-axis at 2. That comes from the numerator. Okay. That would also be true on this one or this one, but that's another point to sometimes look at. And then also the Y-intercept can be helpful. You know, what happens when you plug in a 0 for x and see what you get. If you plugged in a 0 for x, you'd have -2 over -6. It should be at a positive 1/3. Plug a 0 into the second one, and you'd get 2 over -6. You'd get a -1/3. Plug a 0 into the last one, and you get -2 over 4 times 9, which is -2 over 36. And that seems a little off. That's a tiny number, and this is almost halfway. You know, it's a third of the way to the 1. All right, so let's look at 19. What made me think about that is this appears to cross at 2. Okay, also appears to cross at 6. Those are the zeros of the function, and that comes from the numerator. The numerator would have to have an x minus 2 factor, and it would have to have an x minus 6 so that the top part could turn out to be a 0. Okay, because that's what would cause the whole function to equal 0. So I know that much, which means this one's out. Okay. All right, now look at the asymptotes. This means you'd have to have an x plus 1. Say that better. You'd have to have an x equals -1 would be that line, which means you'd have to have the factor x plus 1 in the denominator. Here's a vertical asymptote, so that would correspond to the line x equals 4, meaning it came from the factor x minus 4. All right. Now, when I'm looking at horizontal asymptotes, it appears there is one around 1, it looks like maybe, which means the degree on the top and the bottom should be the same. Okay, so it appears it should be the same on the top and the bottom. So let's see. And that is just 1, 2, 3, that's 8. Okay, so y equal 1. So I need the degree on top to be the same. So this would be 2, 3. This would be 1, 3. This would be 3. This would not. That's just multiplied by 2. So that one, the degree on the bottom would be 1 smaller. Okay, so that would not work. I don't think that's intended to be a squared on that. Okay, then here I'd have 3 on top, and I'd have degree 3 on the bottom, but the coefficient out front would be a 2 rather than being a 1. Okay, so I think it's this guy right here. And then once I think I have it, I could put in a couple additional points, you know, plot some stuff to see if I get what I'm expecting to get. Okay, for instance, it should cross the y-axis around -1.5. So if I think I have it, I can plug in a 0, and I'd get a 4 times a -6. So I'm plugging 0 in here. Then down here, I'd have 1 times -4, getting squared would be 16. So that's a -24 over 16, divide by 4, divide by 2 more, -1.5, sure enough. So I really like that answer. Okay. All right. So I like these problems because it gives you a chance to kind of think about everything. Look at 21. we got a vertical asymptote at x equals -4. That means we'd have the factor x plus 4 and it'd be on the bottom. Okay, here we have a horizontal asymptote of y equal 1, which means the degree on the top and the bottom has to be the same. Okay, and then the coefficients out in front would have to be 1. So all of these fit the horizontal asymptote. Okay, but this one doesn't have the x plus 4 in the denominator, so it's out. Okay, this one's out. So we got it down to B or D. But here's the thing on that. See the little hole right there that appears to be at 6 something? That hole is telling you that it's not defined at 6 either. And if it's not defined at 6, then that means the denominator has to have an x minus 6 in it. But to make it a hole and not make it an asymptote, to make it a fixable problem, rather than an asymptote, you'd have the x minus 6 on top. So it turns out to be this guy. Okay. For it to have a hole, that has to be possible to cancel them out, top and bottom. Okay. Let's go ahead and see what 20 was. Oh, 20 was just asking for the domain and range. So you think about this set of points, you think about this set of points, and you're trying to tell me the domain and the range for those. So see how it goes. There's x's from -infinity until you get really close to -2, and then from -2 on to +infinity. What you do is you just put a parenthesis on that -2. Okay. Now the range, see how it appears that the function is all above the x-axis? That means the range goes from 0 on up. And it appears to have a horizontal asymptote there, so it's not going to hit at 0. Okay, so it's this guy. Okay. All right, so we're doing a lot of these examples. Let's see what we got here. All right, you should pause the video and then work out 22 through 25. Let me get you to do, wow, there's a million of these. Yeah, why don't you pause the video and then do all the ones dealing with the graph. So do 22 through 30. Okay, and I feel like this video has gotten kind of long, so I think I'm going to pause it and come back and do some more on the next one. So we'll start right here with 22. You go ahead and try to work 22 through 30, and then we'll come back in the next video and look at those.